This video introduces a lightweight ProApproX system as an ongoing work towards a probabilistic database management system using XML technology capable of efficiently querying discrete probabilistic data models. All along the demonstration, we compared to the performance of the FLTP algorithm proposed by Kimmelfeld, Kusharovsky, and Sergeev, whose implementation has been kindly provided by the authors. FLTP computes efficiently the probability of a query by means of dynamic programming and achieves high accuracy of results. Nevertheless, it does not support either long-distance dependencies or value joins. Let's begin by presenting the mondial dataset on which experiments were run. This XML file stores information about countries and has around 124,000 nodes, and compared to other popular XML databases, it is quite deep. In order to test the performance of FLTP, the authors implemented a randomized algorithm that transforms an ordinary XML document to a probabilistic one. The main interface of ProApproX gives the possibility to query the selected P document with the expat language, including join predicates but excluding for now position, aggregation, and negation queries, a perspective that we aim to achieve in the future. For example, here is a query that asks for mountains with a height greater than 5,000. We actually focus on Boolean queries, which means we look for the probability of the yes answer of this query. The next step is the selection of the evaluation strategy. Let's begin by choosing to run all the methods. Before sending the query, we might want to look at the setting related to the approximations. If we select the first option, that runs a multiplicative approximation with a given deviation tolerance from the correct answer and a confidence interval of 95%, the algorithm uses Hoeffding's bound to estimate the optimal number of trials to conduct for the approximation to meet custom precisions on the intended result. Let's keep the default settings for both approximations, choose to run the FLTP algorithm also, and run the query. So we've got 22 matches independent up to intersection, so that the independent evaluation can compute the exact result very efficiently. The additive approximation also performs very well intuitively because the result is a high probability. We can rerun the query and select to plot evolution of the results in order to observe the behavior of the computed result over the different trials performed by both approximations. The opaque area around the curve represents the evolution of the error interval given by Hoeffding's bound at each performance trial. The next query asks for a country having descendant text nodes Indonesia and Muslim, and a population attribute node whose value exceeds 10 million. 2 matches for this query, and the value of the results is very low. Additive approximation gives relatively poor precision, whereas multiplicative ends with a high accuracy and performance. Here, we can refine the precisions for an additive approximation, change the error from 0.05, for example, to 0.005, and rerun the query. The convergence is obviously possible, but slower. The next query is a 5-node query. Independent evaluation is not possible, and the performance of additive and multiplicative approximations was comparable. We can run approximations with indications for the convergence detection. So we say that if for 1,000 consecutive trials the deviation between generated averages is less than 0.0001, the computing should stop. A third option would be to run the approximation with a given number of trials over the patterns. The next query represents a big number of matches, so we select to run adequate strategy. The system would pick the additive approximation, surely much more faster than multiplicative computation. Finally, we test the query with a join predicate that looks for countries having a descendant node name equal to a descendant attribute node name. This kind of query is not supported by the FLTP algorithm, but ProApproX deals with it. And additive approximation seems to be here the best strategy to follow, since the number of matches is very high.